and welcome to Kickstart online seminar here at Glasgow Caledonian University and our online webinar. My name is Branka Dimitrijević and I will moderate today's event. Our seminars and webinars disseminate outcomes of feasibility studies and academic consultancies that have been developed in collaboration between Scottish universities involved in this project and Scottish small to medium-sized enterprises. The project is supported by ERDF, European Regional Development Fund, and the Scottish Government CIC program. We have already published 10 webinars, 23 video recordings from conferences, and 8 issues of our online magazine Innovation Review. During the summer, we reorganized all these outputs and provided them in our knowledge base, which is available on our website. And it is divided in 6 headings: decision-making, planning, design, construction, refurbishment, and performance. You are very welcome to check our past outcomes through this knowledge base. Before I introduce today's speakers, just a few housekeeping points. This is a live event, and it might happen that we have a fire alarm or there is a power cut, as it happened during our last webinar. If that happens, we will have to stop and we will continue later. If our online viewers cannot join us, they will be able to watch our video recording a few days after the webinar. We plan to finish around 1:30, but online viewers can use chat facility to ask questions at any point. These questions will be read during the question and answer session after the presentations. We plan to finish at 2 o'clock, and if some questions were not answered by the time, the speakers will answer them by email. So today's webinar title is Synergy of Fabric and Energy Conservation in Older Historic Properties. This was a feasibility study undertaken by the researchers at Edinburgh Napier University and the Morrison Partnership. Today's speakers are Julio Bros Williamson from Edinburgh Napier University and Dr. Cameron Purdy from the Morrison Partnership. I will kindly ask Julio now to start his presentation.
Good afternoon. Thank you very much, Branka. I would like to start by saying thank you to Kickstart Online for the funding and for this opportunity for working together, myself at Napier University and the Morrison Partnership. I would also like to thank the people who are joining us here in this room and people online. I'd like to welcome you. And also my colleagues in the Institute for Sustainable Construction and the Scottish Energy Centre for the work that we're going to present here, and just the help they've provided. The topic of today is to do with historic buildings and how appropriate refurbishment is conducted on them. The title is Synergy of Fabric and Energy Conservation in Older and Historic Properties, and focusing on a particular case study of a building that the Morrison Partnership architects are undergoing, and it's a property in the town of Alyth in Bergowrie in Perthshire, and it's a View Park house. Just to explain a bit about the contents of this seminar, this webinar, I will start with an introduction, just explaining a bit on some of the aspects of this consultancy and this work. I will also talk about the ways our partnership between the Morrison Partnership and ourselves has worked, and what the different key drivers of the project have been. Then I will pass on to Dr. Cameron Purdy to explain a bit about the building and the current state of it, with some photographs, etc. I will then look at the energy mix and the aspects of the energy consumption of this building, and start explaining about the methodology of the study, and looking at the two key factors of fabric intervention and energy, renewable energy measures in the project. And then I will conclude with some results and conclusions. I would like to start with an introduction and really highlighting the importance of the refurbishment of older properties, especially in the United Kingdom, where there's particular interest in preserving our heritage and buildings, and also the sheer amount of current stock buildings that we have. Quoting some of the Carbon Trust and Energy Carbon Trust kind of research, it's estimated that 60% of buildings will still be standing by 2050 and will still be built. So there's a big concern on addressing the issues on energy efficiency and sustainability around these current stock buildings. Most of the focus these days is on new build, mainly because of the building regulations and how it's been focused on new properties. But there has to be this shift or equality between new and current stock, and also into historic buildings. A great deal of CO2 is emitted by buildings in general. And by addressing and dealing with older properties, a lot of carbon emissions can be saved, mainly because of the embodied energy that these structures have, and the amount of energy that can save by reusing them. There needs to be a lot of research and development also into the material use and this interaction between new materials out in the market and older structures and older elements of buildings. As we all know, the housing sector is got an important role to play in terms of the characteristics and the structure in residential developments. A lot of your new builds are big in size and split equally. Older properties and current stock have to be addressed. It's estimated that between 40 and 50% of the UK's CO2 emissions come from buildings, and 2/3 of that is from the domestic buildings, domestic sector. So there's a big concern over that. And out of that percentage, 25% of those CO2 emissions come from older and historic current stock buildings. So again, very important to address them. The Scottish housing emits up to just below 18 million tonnes of CO2 per annum, and that comes about to 8.5 tonnes per dwelling. So there are a lot of issues on buildings contributing a great deal to carbon and the amount that's emitted. For this reason that dwellings, existing and current stock buildings, historic buildings have to be dealt with and refurbished. And it's not only because of its heritage or its historic significance, also because of its social significance in terms of communities and the location and the value it presents to society. But it's also important to save energy. Thermal comfort is important for the residents of these buildings. So it's something that has to be also addressed and is important. The consultancy provided was an academic consultancy between Edinburgh Napier University and the Morrison Partnership. And there were a lot of issues with the building that we had to address. But I mean, the main objectives of the study were to reduce energy, to increase thermal comfort within the property owners, and also to create ways of using renewable energy or more sustainable energy production into historic buildings, and in this case, in this case study. We were also trying to create an understanding between the building and how it's operating, and also try and provide this consultancy for further work for the architectural practice, and addressing issues like material specification. We deal with a couple of examples. The intervention approach, the procedure, and how that should be approached, how the refurbishment should be approached. And again, this adaptability of renewable energy into current stock buildings. And hopefully, with that, with the work that we performed, a new architectural solution could be implemented into the project. The key drivers for the project are really the big issues in terms of energy and the rise in prices and fuel prices. I will talk about that later on, but it's really important how much the current occupier is spending in energy. So that's a big driver. Trying to not depend 100% on grid connections, also quite important. The global threat of the growing threat of global warming, a big issue in terms of reducing carbon emissions from buildings. Very importantly, trying to meet CO2 targets imposed by the government. We believe that one of the ways is to do that. In order to do that, is to address historic buildings and current stock buildings. As the title indicates, we're trying to create this synergy between fabric intervention and energy. So that's an important factor of this study, how to address these two issues into this historic building. We're also interested in obviously achieving better health standards in these buildings, and to create thermally comfortable spaces. I'll now pass on the microphone to Cameron Purdy, and he'll talk about the current situation of the building.
Very much, Julio. Good afternoon, everyone. I'm going to take you through a middle phase in the presentation, which will explain a little bit about the building, its history, a general overview of the fabric elements in the building, the client needs, and also give you an understanding of the existing building and how it has come to be over the years. The history of the building, we understand, was built sometime in the early part of the 1800s. We don't have any specific date, but it does appear on the first Ordnance Survey map in 1856. It was originally built as a dwelling house and remained as that right through 1900s to 1922, when it became a local cottage village hospital, and it was particularly for maternity use. And that explains, or begins to explain, some of the evolving extensions that this building has. It continued to operate as a cottage hospital with maternity facilities through until around 1966. And at that point, it was purchased by the group called Enable and provided respite holiday accommodation for mentally handicapped young folk. It remained as that through until the mid-80s, when it was sold and then reverted back to a dwelling house. So the history of the building is largely about how people, for different reasons at different times, have created extensions to this building. And we have been now dealt with our current client the issue of how can we restore this building back to a sustainable dwelling house, a dwelling house that provides them with the accommodation that they need, both as a house but also for their businesses. There are a number of businesses that they have which they operate from the house, and you will see in some of the later proposals that we have a large area which has been set aside for their home business. I'm going to take you now through the different elements of the fabric. And first of all, we'll look at the walls. The main part of the building is simply a sandstone construction, as you would expect from the early 1800s. It's got a typical cross-section with infill rubble and a lath and plaster internal lining. There are quite a few decorative cornices in the building, a number of very fine skirting boards and other window features. The existing timber shutters are all still in place. So there's quite a lot of features inside the building that we have to respect and retain. However, the building at the back, which saw most of the extensions and alterations over the decades, was in fact built with brick and provides, unfortunately, a fairly cold area to that part of the house. And that is perhaps one of the main reasons that the client was looking to have alterations, refurbishment and extension work carried out. This is the principal elevation facing more or less south. It's not the elevation to the street, but it is the principal one. A very fine sandstone elevation. To the rear of the property, on the existing part, again, sandstone and traditional slated roof construction. Here you begin to see, as we pan round the rear elevation, we see a mixture now coming in of some solid brick walls from the early part of the 1900s, when they were built as part of the cottage hospital. And this view gives you a slight panoramic of the rear of the property. You can see already there are issues here, both in terms of the solid brick walls, some of the roof lights, especially on what was in fact the birthing room on the left-hand side of the screen. There are a number of issues there where clearly there is a great deal of energy being drained from the building. These are very cold spaces in that northeastern section. This would have been typically the original view of the house when it was built, say in the early 1800s, showing you a view from the southwest part of the building. It's a fairly fine looking period mansion house. The roof itself is fairly straightforward. It is just simply a timber construction with slates. There are some flat roofs in the new extension pieces to the rear of the building, but by and large, most of it is covered in slate. The floor is a timber suspended floor with obviously finished floorboards for the look of the property. There is a small element of concrete floor along at the far end of the building where the hospital areas were. That is, of course, maybe to be expected. There is no insulation in the floor, but there is a modicum of insulation in the roof space. Here you see typically the floors exposed. Fortunately, we are able to get pretty good access through the underbuilding to most of the ground floor areas, and that will provide us the opportunity to do some upgrading in that area. The windows, most of them are single glazed. They're quite drafty. I think there needs to be quite a wee bit of draft proofing needs to be done to reduce the amount of unintended ventilation in the building. Similarly, the doors as well are quite ill-fitting. The roof lights and skylights again provide quite a problem in terms of the amount of energy that's escaping from this building. Here you see a typical view of the single glazed window with shutters still operational, and we would recommend making sure that the shutters can come back into use as part of energy saving measures. Here, some of the internal corridors with windows which lead into other areas of the building, and also the roof lights showing fair deterioration and certainly not particularly thermally efficient at all. We would be targeting the roof light area as one to deal with. And these are some of the views from the upper floor, looking out towards the south from the master bedroom. The current heating system, they have two gas combi boilers. They've been fairly unreliable of late, and one of the aspects that they're looking at was in fact to renew the heating system, and we took that into account in our proposals. However, they were fairly unreliable. In fact, one of the boilers has been giving some trouble of late. The only other heating they have in the house would be typically through the old log fires and also a couple of wood burning stoves which are located in the house. And finally, there is a small fan heater. And these heating elements are seen here. The two combi boilers. This is the boiler room. It's fairly large and will allow us quite a bit of space to be able to consider some other type of boiler system which maybe is more sustainable. And here showing some of the wood burning stoves, and there is one, funnily enough, on the upper floor which is in fact at the moment heating just the corridor space, which, as you will see in some of the pictures later, it's the corridors and common spaces in the building are just as large as the rooms. Again, a typical log fire. Now let me just explain the client needs. Effectively, the client wishes the house now to operate as a warm and cosy dwelling house with their own business premises attached to it. It's nothing terribly complicated, but in doing that, we're obviously going to be creating different zoning requirements because of occupancy during the day and at weekends. So there's going to be quite a bit of sophisticated control that we need to put into any new heating system. The house itself has been altered at different times by different occupiers, as I said earlier, and so part of what we want to do in looking at improving this house for them is to try and peel back these development layers which have appeared over the years, to peel them back until we get to a point where we have some understanding of a fairly typical wall construction, which will then allow us to design and build the new extension that we need at the back of the building and upgrade and refurbish the fabrics, both for the floor, the ceiling and the walls, wherever we can, away from the existing or original solid wall external walls. The client's main aim really was to try and achieve some kind of carbon neutrality, and that would be where we're obviously trying to head within the constraints that we have, both from cost and the physical constraints of the building. I'm going to now just briefly show an indication about the current status of the drawings. These represent just simply the location and site plan of the building and the proposed site plan. Here is the ground floor plan. We can just take a moment to explain that I think from the slide shown on the wall here, the existing part of the house, the early part, was defined by this area here. There is some uncertainty about this section. This may have been an 1800s extension, but by and large, where you see the thicker walls, this is the original part of the building. This area at the top here was, again, a further addition to the building. I'm not sure the date of that. And then this area to the northeast quadrant on the ground floor, this is the existing workroom for the client, but in fact was the part of the main operating area for the old hospital. And these were some of the ancillary spaces for the hospital. And on the first floor, you see here some of the problems coming out. In this area here, we have a huge number of roof lights, single glazed roof lights, which are causing a huge heat loss problem. One or two areas of bedrooms kind of stuck out on their own, accessed by a number of steps at this point, which indicates this was an addition at another time. The main core of the building still remaining the same, but a small section of brick building here on the upper floor, which we don't know the timing of when that was built. And moving to the elevation, the roof plan first of all. The bulk of it is in dual pitch slate arrangement. In this case here, there is a valley gutter, and the only area of felt flat roof is this area to the northeast. This room, of course, being slated as well. And turning briefly to the elevations, this is the main principal elevation to the south. There won't be terribly much done to that, although there is a terrace to be added. This is giving you some indication in red dotted line of what we are proposing as removals at the moment. And this is to the rear elevation. Most of this is to do with inefficient glazing and the brick additions over the years. So that's me finished on my section. I'm going to hand back now to Julio. Thank you.
Thank you, Cameron. I'll continue a bit more on the study itself. One of the first actions that we followed after a series of meetings with Cameron and other team members was really tracking down the energy use of the building, the current energy use, both the gas consumption and the electrical consumption. So it was very important for us to measure or track down from the energy bills the consumption itself. So we analysed between the 2009 and 2010, between the summer of both, and tried to indicate when gas was used at the most. And it can be very divided into different periods of the year. The kind of winter period is obviously the most consumption and the more costly set of bills, with costs arising up nearly up to £2,000 over a 3-4 month period, and consumption staggeringly up to 70,000 kilowatt hours. Again, the sheer volume of the building, energy and space heating being used constantly in the building, resulted into these extreme uses of gas. In terms of electricity, most of the electricity was used for appliances and some form of heating, with some of the electrical fan heaters in the kitchen, etc. So that wasn't as much. Nevertheless, we did analyse it as well for our synergy between to obtain some renewable energy, etc. So we had to know what the current consumption was, and we looked at it in the same way, different spring to spring from 2009 and 2010. With a yearly consumption in that year of 9,000 kilowatt hours, and an average of 2,500 per trimester per period. So again, not as much as gas, but nevertheless quite a lot in some of the periods around the house. So this was important for us because we were later going to be using those figures to conduct our simulation, which is part of the study. So yeah, just summarising again the electrical use. Sorry, this is the gas use, sorry. And I want to draw attention to the last information, which should be 30,000 kilowatt hours in that first kind of period. And again, quite a lot of energy, quite a lot in the heating bill, quite important there. So again, we used all this information to map out our simulation. So just to explain a bit about the methodology of the simulation and the work conducted, we looked at different options of improving the fabric, and the way we did this was to create a simulation or a test of the current situation of the building. We used a software called SciMap, developed by CADline, which is a two-dimensional study of this building, inputting current building materials, building fabric materials, also adding energy patterns and the amount of energy being consumed in a given period. So the approach was to try and mimic as best as possible the current situation with the aid of the heating bills, and also the different temperature probes which we set in the building to set the given temperature that's been consumed at the moment, used at the moment. So those were kind of the methodology approach. All that information was added to this simulation, this software, and we could obtain similar patterns of use and energy consumption. Once that simulation was in place, we could start giving alternatives to fabric intervention. So the software gives you the ability to change or add to the current fabric. So as Cameron was explaining, the different wall materials and the wall layering, that could be added to with insulation, etc., or different elements. So we had an interesting dialogue with the architects in terms of specification, insulation type, budget was also quite important. Looking at elements of draft proofing in windows and the building fabric itself. Maybe the addition of double glazed units or secondary glazing as well. And I mean, we played around with different alternatives. The study gave us a limit to those changes, which I'll explain later on. But it gives quite an interesting option to have alternations in material use, etc. So the software requires the building plans being drawn or imported into it, and then assigning these materials to all the walls, and also assigning the floor, the roof type, partitions, and the windows and all the openings. So really, you're mapping out the current situation of the building. To begin with, the current situation of the fabric, the software gives you some indication of the U value of these different elements. We can see the stone wall, the sandstone giving a U value of 1.15 watts per meter squared Kelvin. The external wall, the back brick wall that was explained, quite more than the solid sandstone at 3 watts per meter squared Kelvin. The roof at 0.6. The roof had quite a big void from the ceiling to the actual roof, so that lowered that U value, and the floor in the same way. Suspended floor had just over 1 watt per square meter. So that was the current situation that was obtained from the software. The good thing about this software is the way it can show how moisture and temperature difference is happening within the construction itself. So, for example, this is a current sandstone wall where we've simulated and specified the different layers of the wall with the solid sandstone core, a small air gap behind the lath and plaster, so that would be easily kind of identified in a different fabric. Another example with the brick wall, you've got the solid brick wall and just a render, hence the large U value for that. In the same way, the floor with the large void and the timber decks and the timber hardboard on it, with some condensation appearing just after the hardboard and the joists. And in terms of the roof, again, some condensation appearing just above the ceiling height, and some frost as well at certain times of the year. So once we had that in place, as I was saying, there was an opportunity to start suggesting alternatives. We didn't have time to explore it in a great deal, but we did look at key aspects and key solutions that could be an option in line with budget, in line with the client requirements and the architect's perception as well. So we started with the walls, which covers a great deal of the area of the footprint. It's quite a large building, it's quite a big volume. And in terms of the sandstone walls and the brick walls, we looked at adding some kind of insulation onto the lath and plaster. And we looked at different options, and we modelled one in particular looking at Gyproc Thermal Line Plus board, followed by 2 layers of aerogel quilt. And that was fixed to the original lath and plaster. The advantage of aerogel quilt is that it responds adequately to moisture and breathability within the original fabric. So that gave us some new U values. The sandstone from 1.15 to 0.4 watts per meter square Kelvin, and the brick at the back at 3 watts per meter square Kelvin to 0.36. So some substantial kind of improvements on that side. Again, we could have explored other options, but this one was preferred. In terms of the floor, in the same way, we opted for adding a mineral wool underneath the joists with some kind of netting. It was suggested and fixed onto the joists and the hardwood. And again, a U value improvement of 1 down to 0.16 watts per meter squared Kelvin. All these improvements can be modelled in this software. In terms of the roof, in the same way, originally it had 50 millimeters of glass wool in some previous upgrade or improvement, and that was increased with 250 millimeters of mineral wool just above the ceiling, and that gave an improvement of 0.68, from 0.68 to 0.14 watts per meter squared Kelvin. The windows, we could have expanded into maybe triple glazed, etc., but we opted more for double glazed, timber framed, or the option of secondary glazing as well. In terms of the software, double glazing is best modelled. And from a standard 5.7 U value, the double glazing was giving us a 2.8 U value. Again, better improvements are available, but this was the one selected. In terms of draft proofing, it's difficult to indicate the software where you're going to be sealing and realizing this draft proofing. And the way it understands draft proofing is by decreasing the air changes per hour within the building. So that can be modified in the software to kind of simulate draft proofing. We then, with those solutions, try to apply them to different areas and different alternatives within the building elements. One of the options explored was just dealing with the north facade of the building as maybe the first approach to the solutions. So by adding insulation on the floors and the roof and above the ceiling and the top roof, and also installing double glazed windows just to the north facades. We then followed on to adding insulation just to all the elements in terms of the walls, the floor and the ceilings, with no window upgrading. Many times, because of the sheer number of windows and openings, adding double glazing timber framed windows can be quite a big cost. So that was explored as just adding insulation and leaving the windows to one side. And then the last one was really adding all of the options that we looked at, including draft proofing, walls, insulation, etc., and the windows. And just the level of draft proofing was alternated, was explored in different ways. So again, this was modelled. These layers were added to the walls, and these were kind of both the temperature differential between inside and out, and the moisture elements within the walls was explored. This is a brick wall. We've got the original brick wall, the render, and the aerogel quilt, and the board on that. An added plywood board was put just after the quilt, the aerogel quilt, just to give it a bit more rigid, to make it a bit more rigid for any fixings, etc., onto it. In the same way, the sandstone wall, keeping that original lath and plaster, and trying to integrate these layers of aerogel and gyprock board. Trying to keep, obviously, that aspect of humidity within the component. In the same way, the floor, with the added insulation between the joists, and also the ceiling, above the ceiling, trying to improve that up to current standards above 270 mil. In terms of the renewable energy, it was explored not in a great deal. We were more focusing on the intervention in the fabric, but nevertheless we did try and have the synergy, as the title says it, between energy and fabric. We explored a number of options and tried to do a small kind of feasibility study of each, and trying to integrate them onto the building and the current needs. The advantage of the simulation and the software we used is that with all the changes, we would obtain the amount of energy that was needed to keep certain temperatures, comfortable temperatures indoors. So it would tell us how much energy and how much, with each intervention we would obtain. So our calculations were done with the maximum intervention on the fabric, so the maximum savings in terms of energy, and our calculations were done for energy, both electricity and heating, space heating. So we looked at solar PV, wind generators. It's in quite an exposed site. It's not densely located. Biomass as quite an important aspect because of its location again, and solar hot water panels. In terms of the solar PVs, we looked at taking advantage of the rooftop. It's quite a complicated set of roofs, and there's quite a lot of different levels to deal with. There was an option of implementing a small amount of PVs and having some extra support for them, maybe bridging between one roof line and another. But again, that was explored. That would need a bit more research into it. So we did a small feasibility study. We opted for a small 4 kilowatt peak system, which roughly came out to about 10 meters squared of roof space needed. Out of that feasibility study, we looked at around just above 3,000 kilowatt hours being produced by those panels, which gave us a saving using the current, the old feed-in tariffs of £1,600 per year. And this would be obviously complemented with the savings in energy and the bills that followed that. With the feed-in tariff and the capital cost in our calculations, a payback roughly of 12 years was looked at. And in terms of the total yearly electrical use, this calculation accounted for a third of that yearly electrical consumption. In the same way, we looked at wind generators. We concentrated on a 2.5 kilowatt peak system with a mast of 11 meters. That would approximately be generating just over 3,000 kilowatt hours per year, with a capital cost around £15,000. Again, these costs are estimated and could fluctuate. But again, incorporating it into the feed-in tariff, we were expected to receive £1,100 per year, roughly. And with the savings in energy from that, we were thinking, we calculated a payback of around 10 years. And again, this accounted to another third of the energy, the electrical energy being used in-house. We then looked at space heating, which, given the sheer volume of it, given the amount of rooms, we opted for dividing the different uses of the house in different zones, so that the system, the space heating system, both current boilers and any new system, for example, the biomass, could be monitored and used in a more efficient way. So we looked at biomass and having one of these biomass boilers. Wood pellets were kind of explored, and we estimated with the simulation that with all the fabric intervention, we would need a system of 45 kilowatts, which is quite large. But again, that's because of the sheer size of the building. In order to, I mean, that biomass boiler would cost to maintain, and with the cost of pellets, etc., around £4,000 per year, which is quite a lot. But again, it's space heating we're talking about. So with the projection and with similar to the electricity, we projected over to maybe implementing the renewable heat incentive, which is hopefully being introduced next year, October 2012, and which would offer 6 pence per kilowatt hour produced by this biomass boiler, with an expected payback per year of 8,500. So again, these are small feasibility studies just to kind of show the client the different options. In the same way, solar thermal, we looked at solar thermal, evaluated it with the use of evacuated tubes, and we thought it was not efficient enough to fulfill a lot of the gas and space heating that was needed. I mean, it needed a lot of space, a lot of roof space, a lot of panels in order to fulfill the full capacity. So we've really opted solar thermal maybe for particular areas, for example, the kitchen, for hot water in the kitchen, by maybe having 1 or 2 panels. So I mean, with the fabric intervention, with the renewable energy, it's really all that information with the paper written and the results presented to the architects. There were some plans being and solutions being developed, which some of the options were kind of integrated to them. But this is just an indication of some of the proposed interventions. Cameron explained on the back elevation how a series of demolitions of the brick areas were going to be conducted. Spaces being opened up for various uses, dining and kitchen areas. But really, the architects working with the fabric, working with the current building, and trying to produce a kind of interesting approach to this refurbishment. Again, opening up this front area to a terrace that feeds into the dining room and lounges. In the first floor, little intervention, but again, some partitions being developed and changed. Again, opening and taking away the clutter. It seems to be a building that's had a lot of intervention, a lot of owners, a lot of different partitions being used. So the architects have been quite thorough on that. This is the kind of roof view and the roof plan with the terrace there and little change there. Some expansion here at the back with some areas for the kitchen and dining room, etc. Front elevation, not much done to it other than opening up to this terrace. And at the back is where you've got this small extension, the integration of our options and alternatives in terms of the little remaining brickwork at the top and the first floor, and then the sandstone dealing with those walls as well. So looking a bit of the summary and the results that were obtained, quite a lot of, and I've got a table following this, looking at the intervention. We had, with the full intervention and the option 8, which was the one I was talking about, a saving of about 60,000 kilowatt hours per year, which came up to a saving of 1,600 roughly. The good thing about this simulation is that not only it gives you savings in energy, but it also gives you savings in costs, which is quite good to refer back to. So with the different alternatives, by maybe looking at alternating the draft proofing, there was also some considerable savings, although maybe not doing the full refurbishment. There was still quite a lot of savings in terms of energy and cost. And there was also that approach of dealing with the north elevations, which was, I think, a good first step to the fabric, and then maybe in a later stage dealing with other elements. So this is kind of the summary of the fabric intervention, which really maps out all the different alternatives and the different options that we looked at. First of all, mapping out the current situation with the energy bills and the cost of those energy bills, and then trying to simulate that and obtain similar current figures with the model. And as you can see, they're quite similar in that current situation. And then with the different alternatives, there was savings in terms of cost and energy, And as you can see, that figure goes down to the most kind of the full intervention. Are these two elements, these two options, where you've got considerable savings with both in terms of cost and energy. And that also maps out the plant size for space heating. And we can see that a current quite high, above 60 kilowatt system, down to one just below or around 40 kilowatt system. And we also looked at annual savings as the intervention was done, and also the cost per year on energy. In terms of the conclusions, obviously it's, our prime focus between our consultancy and the architects was addressing the refurbishment and addressing the refurbishment in an appropriate way, and looking at materials in a big way, looking at the embodied energy of them, and looking at results, and trying to integrate these new materials with older fabric. I think that was quite important. We're obviously looking at the aspect of an ecological approach and saving carbon, and also looking at budget and how viable it is to conduct these changes. A lot of these historic buildings and current stock buildings have to be taken case by case, because most of them are different in their fabric and their material use, and also the users are different in all cases. So there were lots of carbon savings and cost savings. For example, this is for every intervention and every option, we mapped out the savings in terms of energy and kilowatt hours from the original, and looked at how much CO2 in tons was saved on each one. And in terms, just looking at, again, all the alternatives, including the two current, with the energy bills and the simulation itself, how different options would give you different savings, and obviously the idea is to lower that as much as possible. With the last two, with looking at the full intervention, indicating less CO2 and less energy being used. I think that's it. That's the end of that. I think we'll follow with the questions. Thank you.
Thank you very much, Julio. Well, now we can start with questions. Let's just see whether we have any. Yes, we have some questions from audience, and yeah, we will see them now online. So the first question is from Dan Hubbard. With respect to air permeability, what was the figure used for air changes before refurbishment, and was this assumed or measured? What were the anticipated results post-refurbishment?
Well, it was assumed. We didn't conduct any air permeability tests beforehand. And it was assumed at 2 air changes per hour, because it's quite a leaky building, and it was quite seeping quite a lot of energy.
Okay, well, let's see. Next question from John Gilbert. Aerogel at 5 millimeters thickness is very expensive. At 20 millimeters, it is very, very expensive. It is also difficult to fix, as screws tend to snag with the filament of the aerogel. It is, however, a useful product, but I'm not clear how cost-effective it is yet. Also, had any consideration been given to the ability of the stone walls to dry out given that a fairly impermeable finish is being applied to it?
Yes, I mean, aerogel is quite expensive. As far as I know, it comes in 10 millimeter layers. So 5 millimeters, I'm not sure that it exists. 5, yeah. So yeah, it's quite an expensive material. But because of the savings in space, we're talking about very thin thermal solutions. I think it was a good alternative. In terms of the fixings, we proposed, apart from the gyprock board, a plywood fixing behind that to enhance that fixing and to make it a bit more stable. Yeah.
I would say to John, thank you for your comments. That's very helpful that those are shared. As we stand at the moment, it is unlikely that we will be actually doing anything to the existing lath and plaster wall. That is not at the moment on the agenda for the proposed tender issue.
Could you explain why it's not on the
it's
agenda?
partly to do with cost, but also to do with trying to target areas where we have least cost and least intervention for maximum energy return. And at the moment, that having looked at it with Julio, that is not an area that necessarily we would be promoting with the client at this stage.
Okay. Here is another question from Diane Hubbard. Is the rare brick extension a full brick, thick or half a brick? Thick or half a brick? If it is a full brick thick, the U value of 3 seems very high compared to the test results from the studies such as the SPAB work, where 1 brick thick solid walls have been measuring at considerably less than 2.
It is a full brick. That's how it was simulated. I mean, the way we simulated and a lot of the material specs were obtained from the software itself. So maybe there are some variations and some scope for addressing and rectifying that. But brick in particular was from the material choice in terms of the software.
Okay, let's see another one. From Anne West, given the high capital cost of the fabric intervention, how long is the anticipated break-even period capital cost thermal savings? Are traditional features to be reinstated?
We didn't explore the kind of return and the payback from the fabric interventions, mainly because we didn't cost them. And we didn't obtain that wasn't part of the scope of the study to obtain a capital cost. So we didn't approach it that way.
And if I can just add on this point that we are seeking to retain as many of the existing features as we possibly can, and in fact the shutters will be in where they're jammed and they will be freed, and we'll be doing all kinds of things to bring the older part of the property back into the way it functioned before previously. And in contrast to that, where we're able to do demolition and other refurbishment work, these will be the areas where we'll be targeting the better specification in terms of wall and roof insulation and so forth.
Thank you very much. Let's see another question from Anne West. Does the alteration of feed-in tariff for photovoltaics affect the attractiveness of this system?
Yes, it does. I mean, it's quite a radical change. Half of the feed-in tariff being introduced, but it obviously affects the payback. It just really means that it's extended slightly, and that's just unfortunate.
It is a well-made point. I seem to keep saying that things have moved on. It's largely because the project is still, even now, dynamic. We are continuing to dialogue with Julio, with the client, about what we can do to the building. And with regard to PV, that is not something at the moment that we are looking to recommend to do. I also privately have just some small concerns about mounting such equipment on the roof of the building, both from the point of view of its aesthetic, which I think would be extremely unfortunate, but also from the point of view of health and safety, because when you put constructions like that on the roof, it's not a matter of, well, let's just leave it until it either goes wrong or it's broken or something needs fixed on it or it needs annual maintenance. But you also need to be considering how the fixings, whether or not the fixings to these bits of equipment are causing any deterioration. So to me, in terms of people going on the roof, I think there are quite a number of health and safety issues for people clambering over a slate roof with quite a high front elevation on that building. And at the moment, it's not something that I am promoting with the client.
Thank you very much. The next question is from Laura Patterson. By dry lining on top of the lath and plaster, how were period features like window surrounds and cornices dealt with?
This was an option that we were looking at, but it is not an option that we are implementing. Because there are obviously, as Laura correctly says, there are serious issues to do with the way in which the wall then meets both ceiling and floor. And for practical cost purposes, as well as I believe hydrothermal purposes, I think that is not a promotion of a solution that I would be behind.
Next question is from David Whitelaw. Did you consider ground air source heating instead of the biomass option? If not, why not?
I think, again, it's because of the scope of the study. Ground source could have been an option. It just wasn't explored. I think there's site restrictions as well. No?
Well, there were some site restrictions, that is true. Again, a very well made point. My own personal experience of air source has not been great. And I can't honestly put my name to anything on the air source side. I'm finding both noise and other issues to do with coefficient of performance for air source, especially in the location where it is. I mean, it's in the foothills of the Perthshire Hills. It's very, very cold up there. So there are issues that would lead me away from air source. We did speak to the client about ground source, but again, it was partly to do with restrictions on the site and also to do with the likely cost of that. There is, of course, the issue that the client has got a budget, and we have to try and somehow or other eschew a solution that will give the balance between the investment of the energy policies together with what the client actually wants in terms of the physical spaces and accommodation that they're actually desiring.
Next question is from Bern Balf. Do you have concerns about installation of vapor control layer on the inside of the lath and plaster walls, thereby removing breathability? Do you plan to maintain a ventilated airspace between the lath and plaster and the masonry?
We've been told, and we deal a lot with manufacturers on aerogel, and they've repeatedly said that a vapor control layer is not needed because of the nature of the aerogel itself and how hygrothermal it is. And the ventilated airspace, yes, I mean, that's something we because aerogel is known to be not a barrier for breathability as much as other products. we are kind of enhancing that through the skirting boards as well, and any other.
Okay, another question now from Ben Glennon. Did you use any particular computer software to assist in calculating the cost savings and carbon savings?
Not for this work. We do usually use PV software to the sizing and the economic side. What we did use was an Excel spreadsheet with given values and a feed-in tariff, etc. A bit more kind of simpler than software.
Another question from Diane Hubbard. Following on from my previous question on air permeability, did you consider separating the air permeability of the fabric and air flows relating to, say, flues, which could be a cheap way of reducing space heating load?
No, we didn't. It's a fair point. We didn't explore flues or looking at that side of the air permeability. No, it could be a good solution, definitely.
And there is another question from Diane. Following on my previous question on air changes per hour, did you consider separating the air?
Yes.
Oh, that's the same one. Sorry. I thought, oh, it was repeated somehow. Let's see. We have also a question from Fan Wang. Did you also look into the effect on thermal mass of the solar stone walls by internal insulation installed?
The simulation itself does take into account thermal mass, and with the different views of the different layers and the calculations of energy retention, etc., it does take it into consideration, but not separately. No, we didn't do it separately.
Okay, thank you very much. We don't have any online questions from online viewers, but we have some experts here in the audience. Maybe they could ask some questions. Anyone right now? Yes? Please introduce yourself. You will get a microphone and please ask the question.
Thank you. Richard Atkins. I wear various hats, but I chair the Royal Incorporation of Architects in Scotland's Sustainability Task Group, and about to start a PhD here at Glasgow Cali. Did you consider, as part of the heating ventilation strategy, looking at either whole house mechanical ventilation with heat recovery, either with or without any form of solar slate technology as a preheat?
Simple answer, no.
Yeah.
Again, it's the scope of it. This is an academic consultancy. It was little time to explore all the solutions.
Do you think that might be a strategy that could again help reduce the energy load in terms of minimizing heat up times for ventilation air?
Yes, I think there's a question mark on how to implement it into older properties and how that would fix with ducts, etc. But I'm sure there's a solution, that's something that can be explored. I don't know if you want to add anything.
No, but I'm sure, thank you kindly for your comments, Richard. I'm sure that they are aspects which we will continue to review with the client. I should say that the project, even as we speak, we still have not applied for the building warrant. So there are many issues that, along with Julio and the client, we will still be exploring. As Julio says, it was an academic consultancy, somewhat limited, but nonetheless, we found it extremely helpful because what it did was it gave us very good grounds for trying to make some early strategic decisions about the energy and the fabric and how we could take the project forward. Because as you understand, we found it a fairly complicated building, because there are those different types of construction right across the property. So when you start tinkering with one, something else starts to go wrong. You need to go back. So three-dimensionally and constructionally, it's been a challenge, but we found the opportunity of this early discussion helpful in policy making, and you are quite correct in looking at some of the more detailed aspects as we now proceed to making a warrant application, and thank you for your point.
Well, just to follow up on that, would part of the outcome of this study be that there is no simple magic bullet out there? It is, as Julio I think said right at the beginning, it's a matter of looking at the individual building, how it's going to be used, how it's being used, all the things that you talked about. There isn't a simple policy which we can press a button and that magically solves all these issues. It is a design solution, not a policy implementation solution.
Yes, I would entirely agree. That's a well-made point, Richard. Thank you.
I think that's where the importance of academics or other specialists working with the design specialists and profession and architectural profession is very key. It's got to be parallel, and that's where options can arise in different stages.
Yes, and as Richard well knows, the detailed information that is now required in order to be able to understand the energy performance in any buildings, be they new or existing, is now becoming quite a sophisticated arrangement, certainly here in Scotland with the Section 6 in the building standards. It is an extremely difficult and challenging section to be able to answer. And for that reason, I think that there are many small and medium-sized businesses out there that could well do with this kind of helpful information from the experience and knowledge, much more detailed knowledge, that the higher education institutes are able to give to the likes of companies like our own. And I think that's probably a good thing to promote in response to, as you well know, Richard, the difficulties of achieving satisfactory Section 6 compliance.
Thank you very much. We have one more audience questions. Please introduce yourself.
Anna Poston from Glasgow Caledonian University. You mentioned the layering and zoning of the building. When you were looking at the different options for improving energy efficiency, did you explore the building use patterns of the occupants, working with the clients as to how maybe they could change some of the locations of some of the most used rooms to fit within those zones, for example, the office, and how they could then improve the energy efficiency partly through their occupation as well as through the other measures that you've mentioned?
Yes, definitely. I mean, that was, although myself with the client, there hasn't been that intervention, but with Cameron and the team in the Morrison Partnership, they're fully aware of the client's needs and pattern of living, and especially with the analysis of the heating side of things, we did discuss the usability of the building and the future, and how the different areas were kind of proposed and new alternatives in terms of space, and it's the different zones that we assigned in the software were in line with future kind of expansion and use. Looking at the living areas, the kind of dining areas as a core zone, and the majority of the use of the building, and then bedrooms, etc., and the office uses. So yes, definitely.
Can I just add to that when we originally visited and spoke with the client, what we would say would be the eastern wing of the property, which was typically the old hospital areas, was by and large just simply closed off. They were actually unheated areas in the property, and they were actually extremely cold because they just simply couldn't manage those areas with the heating requirement, and they were trying to live within the existing or the original domestic dwelling house that was there. And part of the briefing exercise at the beginning of our involvement was to find out how we could unlock those spaces to make them either a standalone business area for our client or whether they could be integrated with the property. So there were times when we went through phases where it was a standalone part of the building, although attached. But latterly, we decided with the client that to have some kind of internal link as well as an external access for the business, and then looking at the use of the dwelling house itself, because although there's quite a lot of space on the ground floor, there aren't actually apartments that might have been used as bedrooms, where we might have even looked towards maybe even cutting off the dwelling house area into a ground and an upper zone. The upstairs apartments had to be used as the bedrooms because ground floor were predominantly large apartments for reception. And so all those things have been talked about and spoken about. But you do raise an important point, and thank you for it, because the issue really is, how do people live in these large properties now? How do they live? Can, in fact, their living patterns change? Should they change? Remember, when this building was built back in the early 1800s, people were walking around with far more clothes than we would have on. People nowadays are walking around in T-shirts in some of these buildings, and they're sort of moaning about the heating. But the truth of the matter is, these buildings were never built to operate in that kind of social environment. So there is, I think, probably across the country, in terms of these older properties, a need to re-educate people to understand that you can't actually live in these older properties in a modern lifestyle. You need to think about how you can actually, with those high ceilings and quite hard to heat rooms, how you should actually be thinking a little bit more about putting on an extra jersey, or just, if you purchase a property like that, accepting the consequences of ownership, which are that you have to dress in a suitable way. If you want to walk around in T-shirts, then buy a better heated building, and one that is more thermally efficient. But you do raise a good point about social aspects to the use of properties, which has an impact on energy use.
Thank you. Just two quick questions. One from Jerry McGuigan. Please excuse me if I missed this earlier, but was there any natural insulation considered on the project?
Not considered directly. It was part of the options that we explored. Personally, it would have been a much better approach. But again, it was impossible to test all types of insulation.
Yeah, although it is important, we are considering that sheep's wool or hemp fabric or fibre would be something that we would be putting in order to allow the building to continue to breathe in terms of our floor and ceiling insulation.
Two questions from Dave Tremlin. Did I hear correctly that 2G modeled better than 3G? And another one, just a second. And why wasn't a low E plus gas filled unit considered to get the U value down to around U 1.9?
Again, it was one of the options, the double glazed simple approach and glass coating. There's obviously lots of options out there with better performance, but this study was really looking at a couple of options that were discussed with the architects, and the good thing about the simulation is that at any time we could add these different options and give more solutions to the architect.
And although Julio was looking at options, that's not to say that those options have been adopted. In many ways, looking at the options was as much to rule them out as much as anything else. With regard to low E in the windows, at the moment, my own personal view from the outcome of the study is to, where possible, retain the existing single glazing. If secondary glazing is to be fitted, may do so on the inside for the very large south-facing sandstone elevation. And where we're doing new at the rear, we will be targeting those areas specifically for upgrading to double glaze with, in fact, triple glaze cases. For the areas to the north of the building, which are not just as immediately obvious when you approach the building in terms of its aesthetic.
Thank you very much. As we are now close to the end of the seminar, I would first of all like to thank both of you, Julio and Cameron, and to thank our online viewers and our seminar delegates here. And I would like also to remind that our project still has funding for 19 feasibility studies available and 3 academic consultancies, and that the next submission deadline is 15th November. If you would like to submit applications for feasibility studies or academic consultancy, you will find more information on our website, but you are also very welcome to send me an email or call me. So we look forward to receiving more applications for feasibility